So in continuation with the last class where we have discussed the block diagram and algebra and what we have to do now, in this lecture we will discuss the different rules for block diagram reductions. Where the different kinds of blocks are there, we have to reduce that blocks into single blocks such that there will be single block, single input and single output. That is our actually aim of this study. So here we'll see when the blocks are first, we will learn when the blocks are connected in series. That is very simple. For example, your blocks are connected like this. I will just remove this term R. Sorry, S. So this will be simple R. This is G1. This is G2. This is G3. And this is C. So instead of having three blocks, we want to get it in a single block, right? So what you have to do, you have to just reduce this block into a single one. This is very simple. What you have to get, this is, what is this? Where we will get this G1 into R, because R into G1 will give you there. So this will be the input to this block G2 definitely. So what we will get there, that is G2 into G1 into R, right? So now G1, G2 and R, this will be the input to this block G3. So what will be here, and the C you will get G1, G2, G3, R. So this is your C. So you get C is equal to G1, G2, G3, R, right? So C by R, that is output by input as a whole, is equal to G1, G2, G3. What does it mean? That means if the blocks are in series, that means they are cascadedly connected. What happens? The overall transfer functions or blocks can be written like a single block G1, G2, G3. That is the multiplication of that gain, as simple as that. And you get, this is your C. This is the reduction of the blocks like this to this, right? And number two, already we know that when there is a block feedback path is there, maybe this is your forward path in G, this is your C, and this is your H, feedback path, right? So what you have to do, you see this is a feedback path. Now feedback path identification is very much important, and every step the student normally what mistakes they are doing is that they may be confused about the feedback path and the parallel path. We will discuss about the parallel path. So feedback path means, see the direction of the signal. R is coming to here. This is your error block, positive. That signal goes to there, and from here, this is known as the takeoff point. This is takeoff point, right? This is summing point, this is takeoff point. Takeoff point means here the signal goes to this direction, that is C. Here the signal goes to this direction, that means here also you will be having the value C. Takeoff point means, say for example, this is a path, a signal is coming, right? Say R. So R signal is going there. So there also R, you will get there also R, right? So that is why this is known as the takeoff point. Takeoff point means this is kind of node from where the signal are dividing. The same signal is going to the different branches, right? So now this path already we have developed. What is the reduced block? Reduced block means R, as this is a negative feedback. So we get G by 1 plus GH, and this is your C, right? So this is the reduction of this block. So C by R is equal to, from here you get G by 1 plus GH. That is the second block where the feedback path is given. So number two, number three, we will discuss when the blocks are connected in parallel, right? When the blocks are connected in parallel, and there is definitely the difference between the parallel path and feedback path. So number three is that the blocks are connected in parallel. You know the concept of parallel because whenever you have done the circuit theory analysis, so everywhere you have learned the concept of parallel combinations or parallel connections like this. The same concept comes here also. Say for example, R is your signal. We may call it, this is a takeoff point. So the same signal goes in the three directions. So there also you will get R, there also R, there also R. These three signals are going through three different systems. Say this is your G1, this is your G2, and this is your G3. Fine. So now what happens? This signal coming to a block which is also the summing block. What is the purpose of it? This is plus, say this is plus, and this is your C. So what do we want to get? We want to get C by R. That is our objective. In a single block, we have to reduce this, right? So once we have to reduce this, that means this whole block will be converted into a single block, right? See, if this is R, what is the value of here? This is R into G1. That means this signal is R into G1. This signal is R into G2, and here you will get R into G3, right? So this will be R into G1, R into G2, and R into G3. Now, see this block, all the signals are coming from single directions. That means branching is there. There is a branch, and they are going to the same node, right? So here all the signals will be summed up. What is this? R into G1 plus R into G2 plus R into G3. That means this is your C. So C is equal to R G1 plus G2 plus G3, right? So you get C by R is equal to G1 plus G2 plus G3. So what happens in case of parallel connection of the different blocks? Basically, their gains are added. Their gains are added. Maybe this signal is negative. Say, for example, okay, first of all, I will write this block. This is G1 plus G2 plus G3, and this is C, right? So this is the parallel block, and one more time I will say, so there is a certain difference. The branching, note the branching, all the signals are dividing. That means branching from this point and they are coming back to a certain point, not that the signal direction is changing. So in case of feedback, what happens? The signal going to this direction, coming back via this block to this direction. This is your feedback, right? And this is your parallel connection. So there is a distinct difference. They may be like this from here. So branching is not there. Actually, this is the signal. So direction of the signal is from this to this direction, and that is coming back to the input side. This is not happening in case of parallel connections. There are the different branches of signals. This is node from where all the signals are getting branched, and then they are going to this through these different blocks, and finally they are summed up here. Maybe this is negative. So what happens? This signal, this G1 plus G2 minus RG3, there will be minus, right? So after all, this will be minus and this will be minus. So C by R will be equal to G1 plus G2 minus G3. So depending upon this sign, you have to consider what is the value of that gain, right? So this is the three rules we have learned on the block diagram. When the blocks are connected in parallel, when the blocks are connected in series, when the blocks are in feedback, right? Now these are the very common thing. Now what happens if the different summing blocks or takeoff blocks can be shifted to either side of the block? So somewhere in many of the cases this is very much actually common for practice. to do this type of jobs. So, like say our rule is, next rule is like this. So next rule is to next rule is that when shifting of a takeoff point from left hand side of a block to the right hand side of that block of that block. That means if I draw the diagram, then it will be a bit clear. The shifting of a takeoff point. First of all, see the original diagram I see. This is R, and say this is your GS, this is your CS. This is the kind of system is given to you. So here also there may be takeoff point, here also there may be takeoff point. So what is our criteria is that you have to shift the takeoff point from left hand side of the block. So left hand side of the block we consider is this point, right? So this is the point. Here there is a takeoff point. Now you have to shift this point. Maybe this point is say A. This is to be shifted to these positions. So once this is shifted to these positions, definitely there will be certain manipulations on the defined blocks. What will be that? First of all, this is your R, so takeoff point. So what is the value of the signal you get? This is definitely R, because R signal from here you are taking off. So next step, you see CS is equal to RS into GS. Fine, there is no problem. Now once you have to, the main rule what you have to keep in mind is that whenever you are shifting any point, maybe takeoff point, maybe starting point, whatever, from any side of either side, that is from left hand side to right side or right hand side to left side, what we have to do, we have to rewrite the blocks without changing its value. Right? How you will write this R? We will write here, this block will remain same, this is your C, no change, and this is also R. Here the point is R, right? That means when you move this point, takeoff point from here to here, that means this whole thing will be moved, right? So whole thing is to be moved, that means here you will be moving this block, right? And we will write it R. But I have already discussed, again I am talking that this is R, this position will remain same, this is G, this will remain same, C, this will remain same, only this R, that means this arrow, find this arrow is directed left side, where the value will be R, that is left side, this value is R, only this point is moved from there to there, right, from left side to right side. So what you have to do, we have to manipulate like this. Now what is the value of C? That is R into G, right? We are just omitting this S part. So R into G. If this is R into G, definitely if you multiply here with 1 by G, so what we get? Here you will get R into G into 1 by G, that is R. So we will get R. So how it takes the shape? That means if any takeoff point is shifted from left hand side of any block GS to right hand side of that block GS, that means here in this path what you have done, you have just add the gain, which is the inverse of the gain of the block, which from left hand side to right hand side the operation has been made, right? So if this value is G2, then 1 by G2. This value G3, 1 by G3, and so on. So any block, you can take any block, you can shift any point from left hand side to right hand side by considering that gain will be inversed and multiplied with this block. So this is the shifting of a takeoff point from left hand side of the block to the right hand side of the block. Next rule is that we will shift the takeoff point from right hand side of the block to the left hand side of the block, from the right hand side block to the left hand side of that block. So definitely now the problem will be bit easier. This is RS and this is your GS, this is your CS, right? So CS is equal to RS into GS, no problem. Now there is a takeoff point there, so this is again CS. This is your initial condition, A is there, right? So CS is equal to RS into GS. Now what you have to do, we have to shift this point to the left hand side of that particular block GS. Okay, from A to these positions you have to shift. So what you have to do, you have to keep all this term remain same. We will remain same RS. Okay, we will get GS remain same. We will get CS. The value of the CS must have to be RS into GS. That is also fixed. Now the takeoff point is shifted here, right? If takeoff point is shifted here, definitely this block will remain same as I have discussed, right? So what is this? CS. And what should be the value of CS? CS must have to be this. What was the value of it? That is RS into GS. So whether in the earth, wherever you were moving this takeoff point from left to right, right to left, whatever, the value of the CS, that is RS and GS, will be fixed. So what you have to do? I think you have to multiply, because here the signal is R, this signal GS is multiplied with R, so here we'll get RS into GS, right? So what we'll get? CS is equal to RS into GS. So that is the rule. That means whenever you are shifting a takeoff point from right hand side of that block to the left hand side of that block, what we get? You have to incorporate the gain of that block with the path, right? So this is the rule, another rule, and two more rules are there which are very important. That means rule number 6, we will consider that shifting of a summing block from right hand side to the left hand side of that block. So takeoff point, instead of takeoff point, we will write it as shifting of a summing point, right? So let us take the example. First initial value, that is RS, this is GS. Say a takeoff point, sorry, summing point is taken. Say maybe this is your YS, that is your CS, right? That is a summing block. Summing block is placed at the right hand side of the block GS. Now this summing block is connected to another. That means summing block having two ports. So two ports means what you have to do, you have to just get another input like YS or whatever different kinds of signals you can take. So what is this? So what you have to do, you have to just shift this summing block to the left hand side of this block GS, right? So in that case, what you have to do, you have to do the same thing as in the case of takeoff point we have already done. What you have to do, this RS will remain same. Here this will be your summing point with this same signal notation, that is plus minus and all these things. This has been shifted, right? When this has been shifted, so this ys, this will remain same ys positions, right? And after that there will be gs, because gs will be in the same positions, and then you will be having the value of cs, right? Now once you are doing like this, then you have to first calculate the value of cs such that your total calculation can be made possible. So what is this signal? Here you will get rs into gs, right? Here we will get rs into gs, and this is rs into gs, this is minus ys. So cs equal to, for this block, mathematical expression we get rs minus this, rs into gs minus ys, right? That is the expression for output. So similarly here also, when you shift this summing point from the right hand side of this block to the left hand side also, so you will get rs into gs minus ys. There will be no difference, right? So how it can be done? Here you see, this is only the rs, right? So if you just manipulate this in such a way, you can take rs, but you will get gs minus ys by rs like structure. So in that case, you get the gs minus ys by rs also. The cs will be equal to rs into gs by ys. Now what you could do, you can do this. There is a block, can add a block c, that is 1 by gs. Okay, so if you just get this 1 by gs multiplied with this block, what will get this here, what will get here? Or in other words, you can just change this by taking gs as the common. Gs, you get rs, because rs is a single, there is no multiplication with any term with the rs. So gs is coming after this block, so gs rs minus you get ys by gs. So gs is the block which is to be multiplied with the resultant of this sum, so ys by gs. So ys by gs is subtracted from rs, so rs minus ys by gs will be coming here, rs minus ys by gs. So with this whole term, if you multiply g, then you will get rs gs minus ys. So that is the term, right? So from here we can see that what is the case when the shifting of a takeoff point from right hand side to the left hand side of the block. In case of shifting point, takeoff point shifting, the same thing was that only this is the multiplication of the same block from where the right hand side of the block to the left hand side of the block we have moved, right? So in case of takeoff point and in case of summing point, the thing is same but just inversely related. Similarly, next term is very easy, that is shifting of a summing point from left hand side of the block to the right hand side of the block. That is the rule, and these rules are very much actually easier to understand. This is left hand side to the right hand side, so we can write it left hand side to the right hand side. So we will write the structure like this. This is a error block. Here you can write it as ys. So this is your gs block and this is your cs, right? So here what is the value of cs? Cs is equal to, you get here rs minus ys into gs. Now what you have to do, you have to shift this summing block from the left hand side of the gs to the right hand side of the gs, right? So all the terms will remain same. So you will put here RS, RS, this will be your GS, there will be no change, and this is shifted here with the proper sign without change, and you are getting CS here, right? So what should be your CS? That is RS GS minus YS GS. That is simple, very simple. That is RS GS minus YS into GS, right? So RSGS, you are directly getting RSGS here, and this YS will remain same, this term. So what you have to do, you have to multiply this with GS. So here you are getting YS into GS, here you are getting RS into GS. So ultimately CS remains RS minus YS into GS. So when you shift the summing point from left hand side to the right hand side, that gain is multiplied to the path, right? So this is the way and the manipulations required to solve any kind of complex block diagrams to reduce it to a single block diagram, right? And there are two more things. One is that breaking the summing points, 3-point summing blocks into two 2-point summing blocks. That is breaking the summing point into number of summing points. What is this and how it can be done? This is very easy. Say this is plus plus minus. Say for example, this is your X, this is your Y, and this is your Z. So at the output of the block, what we get? This is plus X plus Z minus Y. So that is coming, and this is your GS, suppose. So this is your CS. So what is the CS we are getting? CS equal to X plus Z minus Y into GS. No problem. Now, as there are 3 blocks, and normally all the blocks which have been given in defined forms, all we have to convert it into the closed loop feedback control system path. That means whatever the systems will be given, we have to convert it into first we have to convert it the structure like this. This is your C and this is your H. This is the first step. Once you get this, definitely you will get CYR, right? So in order to get this type of structure, you see there is a summing block which may be plus, maybe minus. So 2 input summing block is required. So here it is, you are getting 3 inputs. So 3 input summing block is to be converted into 2 input summing block, right? So how can I write it? I can write like this: X plus Z. So where you can get X plus Z, right? This signal is X plus Z, and this is a 2 input block. Next, what can I do? You can, so this is plus, this is minus, this is your Y. So what is the output of this block? X plus Z minus Y. Now see, C equal to X plus Z minus Y into G, right? So we are getting the same output, and easily now we can manipulate this structure in our known structure, which is the closed loop feedback path structure, from where we can get the overall system transfer functions CYR. So once there is a 3 input blocks, that will to be converted into 2 inputs blocks, right? And last point is that That is not actual point, but things that if two taking take-up points are residing side by side, that means, for example, uh, this is block rs, say there is a block G, and this is your CS, right? So this is the take-up point which is having the value R. This is the take-up point which is having the value R. So maybe this is A, maybe this is B. That is coming somewhere, going somewhere else. So these A and B may be interchanged. So B may be there, A may be there. So you can write it like this R S. Maybe you can see like G1 block. This is G2 block, right? So what we can do, we can just shift this B point here, and with this G2 and A point here with its gain G1, right? And this is your G. Yes. Right. So this is kind where the takeoff points can be interchanged. Similarly, if there are two summing points, that can be interchanged. But one thing which cannot be possible, say RS uh, here you will get G2 like this. So these 2 points, this is basically one node, this is basically another node, this is takeoff point, this is summing point. So this summing point and takeoff point, this interchange, that means this goes there and this goes there, is not possible, right? Not possible. So interchange of the two takeoff points is possible, interchange to two summing points are possible side by side when they are residing depending on their positions, but interchange of the summing point and takeoff points will not be possible, because you see any signal, first of all, this is basically signal coming here, this is another signal coming here, the resultant of the signal is rs plus minus y, right? So that signal goes there. So if you just shift this two part, that means something else, that means this rs goes to g1, rs goes to g2, then the summing or the adding or subtracting is coming in the picture. So this is not possible. So these are the basic rules of reduction of the block diagram, and once you know these rules, definitely you will get the idea how to reduce the blocks of different complex systems into a single one. And in the next class we will discuss some of the problems where these block diagram reduction techniques has been used to reduce the overall blocks into a single block, right? Thank you.